Hello and welcome to another session of Hive. So in this session, we'll talk about Hive bucketing. So what is bucketing? So bucketing in Hive is basically concept of breaking down the data into ranges, which are called as buckets. Now this is to give extra structure to the data so that it may be used for efficient queries. Right? This is the definition of Hive bucketing. Now let's understand it with a simple example. So imagine that you have some data in a table and one of the column is ID. So let's say these are the IDs that we have. We have from 1, 2, 3, 4, all the way up to 1 million records, right? So we have 1 million IDs. Now, every time you want to query something on this ID, it has to scan all those 1 million records, right? So what we can do is we can further divide them into ranges and then call these are basically called as buckets. So basically, let's say if I want to divide this into 5 buckets, so I'll have one bucket here, I'll have another bucket 2, 3, 4, and 5. I have 5 buckets. So now this data I have to divide into 5 buckets. So what will happen is each record, there will be a modulus operation. So if I take as this one, the first record is basically one modulus the number of buckets, which is 5. So the output of it is basically 1. So this will go into the first bucket. Let's say this will go here. So this will have the data 1. Similarly, let's say second record, and now here the modulus of 2, 2 modulus 5 is basically 2. So this will go and sit here. Similarly, this record, the modulus of 5, this will go and this is going to sit here in this bucket, right? Then this record is modulus of 5, this might go and sit here. Similarly, this is modulo of 5 is basically 0, so this might go and sit in the other bucket. Again, you will have another records which is 6. The modulus is 1. So this might go and sit here. Again, this might go and sit here. So what is happening is the data whose modulus is same, like all the modulus of 1 is will go and sit here. So it will have 1, 6, maybe 11 and so on. Similarly, all the modulus which of 2 will sit here. So basically, we are dividing this data into each of this bucket. So now if I do a select queries, let's say select where ID is equal to 10. Now the ID 10 would be the modulus of this one would be 0. So this ID 10 would basically be sitting in this particular table or in this particular bucket. So when you query this particular ID, this is directly going to go and search in this particular bucket now rather than all the other files. This way, we are going to avoid a full table scan. We are limiting the scan to only just buckets. So this is where buckets are useful. Now, these buckets are basically not that common because this is again used only when you wanted to query predominantly on a particular value on particular range of values. Like if you have in this case on the IDs, you are always querying on this IDs, that is where you want to create a bucket. But if you're using any other queries, let's say you're not using a where clause on ID, you're using some other columns, then the bucketing will not be that useful. All right, so enough of this query. So let's go ahead and understand this with an example. So I'm going to the MySQL, and if I look at the tables here on the retail underscore DB, I have multiple tables. So let's pick this table. So let me describe this. Now I have order ID, order date, customer ID, order status. So order ID is basically primary key. So what we will do is let's check this data first before. All right, so we have good amount of data. We have 68,833 records, and the order ID is basically ranging from 1 here. Right, so what we will do is we will enforce this bucketing on this particular column, which is order ID. We will create buckets on this ID, right? So for that, let's jump on to the Hive session. So I'm here at the Hive session. Now, in order for bucketing to happen, we need to enforce some properties. So first property we need to enforce is this has to be a dynamic partition. So we have to make sure our dynamic partition mode is to non-strict. And the other property that we want to enforce is we have to say hive dot enforce, then bucketing. This has to be true. These are the two properties that we have to enforce. Now, when you are enforcing some, when you're setting up some properties, make sure that you see that you have the proper value set, and also make sure that you are writing the right spelling, right? See what happens here is even if you look at this hive.enforce and bucketing or any of this, right? If you misspell any of this, it will not throw any error, and that's something that is kind of not a good thing, but that is how it is. So it will basically take as it is, so you will never know what mistake you have done. I've seen people, say, hey, no, I set this property, that property, but somehow it is not working. Now, why it's not working? There may be different reasons, but one common reason when they set some properties, they have misspelled it. So, if let's say if I put something like this, instead of bucketing, I say bucket and I give it as true. See, this is not correct, but still it is not giving me any error. So please make sure that you have the proper spelling put. And if you set up some property and see that it is not working, make sure that you come back and verify what properties you have set, if it is on the right spell, if you have spelled it correctly or not, right? So this is something that you have to keep in mind, right? So now let's create a not partition table. We'll create a table on the orders. So we'll recreate this in the Hive, right? This order table. Okay, I have this table here, the structure of this table. So basically we have four columns. This is a row format delimited, again fields terminated. We are storing it as a text file, and the location that we want to store is this one. So this is the location. Here we have this data. We already have this data. So if I just query it, this is the data that we have loaded at the beginning. Right, so we have this orders.csv, and you can cat this. So we have this data on this location. So what we are going to do is let's go ahead and execute this table, create this table. So let me go to the Hive session, and I have this table created. So if I do a describe, let me do a describe formatted so that we have all the details at one go. So you can see here the column, all the column names. This is under the database practice and the owner of this table. It's an external table with this location. The data is already present. We have seen this data. This is great. Now what we will do is we'll create a partition table on the same orders column, on the same orders table. So we have this query here. So what we are doing is we are taking the order ID, order date, order customer, order ID. These columns we have, and we are creating a partitioned column, partitioned by, this is on order status. And so this is what we are adding again. So once you partition by order state, you are clustered by order ID into 5 buckets. So this particular piece of code tells you that you want to divide this range's order ID into 5 buckets. So what will happen here is first it will create partitions based on order status. So let's say we have 5 order status. So it will create 5 different folders. Under each folder, what it will do is it will look at the order ID. It will do a modulus operator on order ID, like say order ID modulus 5. And then whatever is satisfying this modulus all the corresponding modulus say values will go into one bucket. Let's say a bucket 1 will have a modulus 0. So your order ID 5, your 5 modulus 5 0. So that will go into first bucket. Similarly, order ID 10 will go into first bucket. 15 will go into first bucket. So this is how it will go. So let me go ahead and execute this query. So we have the query executed, and right, the location here, we don't have any data. We just gave a location. Now we have to insert the data into this location. Now we have the data in this table, orders table. So we will insert the data into this orders bucket from this orders table. So I'll have a insert command, insert into this. This is a partition table. So I will use partition. I'll have one partition order status. This is the dynamic partition. So we don't have to specify any value here. So let me go ahead and pull this data. So I will need order ID. Next would be order date, order customer ID. And of course, we need order status from order. Is it order or orders? Yeah, this is orders. Okay, good. So let me go ahead and execute this. Each order, so now we have, now because we are segregating the order ID into each of these buckets, so it has to go through a comparison, right? So for each folder it has to go through a comparison. Because of this, there will be 5 reducers that will be invoked here. So you will have 5 reducers. This will this will cause the program to run little slower because there is a shuffling of data that is happening into this 5 buckets. So you might find this take a little bit more time than usual, but that is okay. That's because you have 5 reducers running here. Yep, you can see here the number of mappers is 1, but the number of reducers is 5. This is because of the shuffling thing that is happening here. All right, so we have the data loaded. It took just 65 seconds, a little over a minute. Now, if you look at this, right, now first what it is doing, it is loading into partitions. So these are the partitions that got created. And once this partition got created, inside this partition, if you see, for example, this is a partition cancel, right? Order status is cancel. Inside this partition, you have number of files as 5. So this number of files is basically number of buckets. So under each partition, you have 5 buckets created. So let me go ahead and query this particular directory. This is where we have the data stored. So let me clear this. So first we have the partition. So I will go ahead and query this partition. Now you can see here, right? This is 1, this is 2, this is 3, 4, 5. So we have 5 files. Now these are basically buckets. If you look at any of these buckets and if you look at the order ID, you will see that they all, if you do a modulus operation, the result will all be the same. Okay, let me take this one. Now, if you see, right, this is the first column. So all of this, if you do a modulus operator, all of this requires the modulus operator, the result will be 0. So this is why all of them are in this bucket. Now, if you take other bucket, let's pick this bucket. So if you look at this, right, the modulus operator, all of them will have the same modulus operator. So that is why it all ended up into one similar bucket. So what happens is when you query something on the order ID or on the order ID, then it will look for the modulus, right? It will do a modulus and it will know like, okay, this is the output of this modulus 0. So therefore, I just have to check this particular directory. If the or this particular file, if the modulus is 1, I'll have to just check this, or if the modulus is 2, I have to check like this. So this way, instead of going through the entire files or entire directories, we are limiting that to buckets. Now, so this is the advantage of using the buckets. Now we have created this bucket using a partition, but partition is not really a necessity. You can still create these buckets without a partition. Probably that is something that you can try. So here you can just remove this and put it here, and then you can create a table without partitions. All right, that's all for this session. I hope bucketing concept is clear to you, and I'll see you guys in my next class.